Testing the audio. All right, I think we're in a good position. Okay, it looks like we're ready to start. Hi, my name is Evan. Thank you all for joining. In this video, what we're going to be doing is going over how we're going to architect droid. In fact, I've got a bit of audio feedback. There we go. Okay, perfect. So this is one of my early first streams, just trying to get used to it. So thanks for joining. In this video, what we're going to be talking about is how we're going to control this robot just right over here. This little thing here. So for those who've recently seen the video on the other channel, the main channel, which is regarding just basically how the robot was built using specifically Raspberry Pi, using an Arduino and using a motor driver. This video is going to be more about how everything, going into a bit more detail into that, and currently what new additions that has been implemented to actually make this robot a bit more responsive at the moment. Now this robot right here, so now everything's a bit experimental at the moment, so we're just playing around, making sure everything is all good. So before that, thanks for joining. I hope you guys are well. I hope you've stayed hydrated. Hope you're working on whatever you're working on and it's all going good. So now we're gonna go into this actual video, and it's specifically this stream. But what I'm going to pretty much talk about is what is droid for those who just recently joined. Now droid is, the whole idea is it's going to be a delivery robot. In fact, it's a robot. It's a variation of robots. In fact, if you just see right in the top corner right here, there's a smaller version of droid, and you may have seen in the previous video, droid mini. Now the whole idea of these robots is that it can be controlled wirelessly, remotely in fact, so it can, for example, get a specific delivery, or it can be able to fetch deliveries within this compartment right here. Now this little compartment right at the top is something where we can put our payload in, as you may have seen in the video. So if you want a bit more context into just a bit of a high level overview of how this robot was built, have a look at that. Have a look at that on the main channel. So let's do a little bit of a demonstration just to show how this robot works. It's pretty experimental at the moment, so to be honest, I'll be surprised if this actually is able to be controlled at the moment. So for example, I'm using my other PC here, and then I'm controlling this wirelessly. First of all, we're going to make it move towards us by hitting the W command, and if I just press enter, you'll see the robot move, and it's now stopped. Now of course, we're doing this live stream, so there's the naturally inbuilt latency as I'm speaking and when it's reaching your ears. But this is the robot being controlled. We can also reverse it. If you just see me here, we can also reverse it, and I'm just going to press enter so you can also see the latency of it. So let's just go back to the robot itself, and I'm going to reverse it. And this is the robot reversing. We can also make it move left and right, and so on. Now the whole idea of this robot is that it's going to be able to be controlled as a community. So imagine it being used for various sports kind of, or more event driven robots. So for example, imagine two robots racing or so. This is all within the this is all within the scope of what Droid does. Now, how we're gonna do this is that in fact, this robot that you see here, Droid, you can think of it almost as a singular node on the Droid network. So imagine this being one single robot being controlled. We can also add an addition of robots, like the robot you see right on top of the table, which you know as the Droid Mini. We can also add various robots where people can also be able to control this remotely as well. And for example, this can lead to quite interesting events, because think about it, we have two robots and then we can make it do anything. But right now, the immediate scope and the use case at the moment is that we're going to be able to actually make it deliver some food. This is going to be done, in fact, in a video that's coming up. What the whole idea here is that we have the robot. It's going to be able to go to our local convenience store, or in fact a takeaway place, get me some kebab and deliver it back home. And that's going to be a video that will be coming on the main channel. That will be once I'll be able to get one of my friends, one of my good friends, to help out with the camera work. So yeah, that's really cool, and hopefully he'll be something entertaining on that side. Now, the thing about this video and what the goal of this specific stream is we're going to talk about how we went from a robot, for example, a small 3.3 volt remote controlled robot that you'll see in like an Arduino pack, kind of a starter pack, and how can we go from this to something like this. And the whole idea of this video is we're going to be going through the whole thing. So as you know from the previous video, we have the Raspberry Pi. The Raspberry Pi being the brains of the robot. To be honest, it's the thing that's orchestrating pretty much. It's orchestrating everything from the camera to the speakers to the commands it sends to the actual Arduino itself. So think of this actually as the orchestrator. We're getting commands in, for example, move left, and when it says move left, it sends it to the Arduino, just like this. And of course, the Arduino has a bunch of motors attached to it, as we're going to go into a bit more detail. Now, of course, we have the motor itself and we have the motor driver. Now, the motor driver, the good thing about it is that we can control the speed and the direction of the robot. And this is quite good because then we can make it reverse, left, right, and so on. So this is just a bit on the kind of parts that we'll need. So what I want to show specifically is, let's actually go to, let's say, a robot specifically here. What I'm going to do is just show my screen on that. So let me show that. If I can. Okay, it looks like we finally got it. Yeah, so yeah, anyways, so let's start. Of course, sorry, this is a bit of it's very raw, these kind of live streams, so there's going to be a bit of times when it's just going to be absolute quiet, as I'm trying to work Streamlabs and try and get the right scenes together. So let's start like this. Great, we want to build a robot. Forget that we actually have this robot here, and let's focus as if we have a robot and we just got an idea. How are we gonna go from having no idea of what we want to do as a robot, forget that this robot exists. And how, the question is, let's say we went a few months back, we want to build a robot. This robot, and the scope of this robot is going to be a delivery robot that is going to be able to be controlled wirelessly. We have no knowledge of what is going on. How are we going to do it? And this is specifically this part of the video and the live stream that we're going to go around doing it. Now, first of all, it's always good to see some reference points of some actual robots that actually exist. And these are specifically some robot car kits and so on, that pretty much give an actual overview of pretty much of what the components will need. Now, of course, the robot that we have here is something that is much more scaled up, but the reason why I'm showing these specific robots is that it gives us a good idea of a starting point of the journey and how we're going to go from specifically this robot to this robot. So let's go back to these robots. There must be a robot counter. I don't know how many times I've said robot, to be honest. Okay, so anyways, let's have a look at this example robot. Now, this robot we see here, which seems to just be the chassis itself. We have a chassis. If we think of it, we're going to break it down into the compartments, or the parts actually. So, for example, we have two wheels. We have a motor, which is just over here. And in fact, let me make this bigger. We have a motor just over here, if you can see, just out of view, just here. We have a motor here. We have the chassis. We have what seems to be a ball roller, and the reason why they use the ball roller is almost like a third wheel, which seems to be, so it's going to be able to turn left and right relatively easier, which seems to be a ball roller. Anyways, and then we have these motors. Now, these motors are looked to be 3.3 volt motors, 3 volt motors. Without looking too much into it. Now, of course, a 3 volt motor is nothing that would be able to drive a larger motor than like this. And this one, in fact, is using 12 volt motors. But to be honest, we can probably ramp this up to something a bit more like a higher voltage motor. And of course, the stronger, higher the voltage, we can take advantage of a more powerful robot that can go over, for example, hills and so on. And it's a bit more faster, of course. So now going back to the actual robot itself, it seems that these robots are pretty much, it's got a battery, it's got a chassis, it's got a wheels, and it's got the motors. And that's pretty much what specifically forms the robot we have. So in fact, just go into our actual video itself, just building a robot. What I would go to is actually specifically the main part list. So of course, as you can see, this is the droid. This is droid itself, just in the background, and this is droid mini. It's simplified, and the whole reason why this kind of example was shown is that this is exactly the same thing as droid. As the actual package delivery robot. Oh, by the way, if you guys have an idea of what to call these, like droid mini, for example, if you've got a better name, leave it in the comments below. Right now, I'm just calling it droid mini, and I'm probably going to call this droid trooper because it resembles a stormtrooper ideally. So, anyways, that's the idea. Hey, thanks for answering this, man. That's Galanarchi himself. If you guys are looking at this in the future, do visit Galanarchi. He's got his art is just amazing. He does NFTs. You should also look at his Instagram, Galanarchi. It's pretty much the exact same spelling as his username. But shout out to Galanarchi. Really great art. Anyways, going back to the video, what we have is just droid mini and what seems to be now called droid trooper because of the stormtrooper look. They're exactly the same thing, the exact same components. The only difference here is that one's got 4 wheels, the other's got 6. Now, the whole idea is just to show how this was built, as you can see. Now, what we have here is the main parts. So, as you can see from the previous the chassis there, what we have here is that we're using 12-volt motors, and the reason why we're using 12-volt motors is, of course, it gives us a much more droid beast, droid rover. I like rover, you know, droid rover. That's a really good. Yeah, thanks for that. Yeah, droid rover is a good one for the larger one. Anyways, yeah, we got 12-volt motors, of course, so it can give us a higher, make it faster. We've got the motor drivers, and the motor drivers, of course, as you know, the ones just right here, it gives us the speed and the direction. Let's see the autofocus. Okay, this is cool. By the way, I kind of got a new camera because the previous one was the M50, and the M50 has auto shut off, so every time I was always turning it on just to keep it in focus. So yeah, now we got a new camera. Anyways, and we have the microcontroller. Now the microcontrollers, we can use different microcontrollers, but this one we're using is an Arduino. I really like Arduinos because it's pretty much everything in the box, and as well as it's got so many PWM pins, and that allows us to control the motors with varying duty cycles, so it can make it faster, it can make it slower, and so on. So anyways, carrying on, what we have here is the main parts. Now, going back to the example, we want to build a robot. Typically, the main parts of what builds a robot, as I'm saying that, it looks like the camera just went off. Anyways, the main parts that consist of a robot is the battery, of course, and of course the larger battery, it allows us to have more range, so we can go further. So that's a really good advantage. But then again, if it's a heavier battery, that means it's gonna be extra load with the actual robot, which will make it slower. Then in turn, we need a stronger motor. So we'll talk more about these kind of limiting factors later. But without going too much in the kind of digression, what we have is a battery. We have the wheels. Now the wheels are important because it allows us to, of course, roll. Of course, self-explanatory. We got the motors itself, the 12-volt motors. We have the motor driver. Of course, now you know the speed. It can control the speed and the direction, as well as the Arduino. Now the Arduino, as we said, this is more like the orchestrator. It's getting this is the Raspberry Pi, by the way. It's getting the data from our network to control it wirelessly. But the brains of the actual robot, what is controlling the robot, is actually what we have here. It looks like my camera is slightly overheated, so I'm just going to let it cool down for a bit as I was literally speaking. So let me just keep that on dark mode for now as I speak further. So let me just remove this for a second. So we have the actual battery itself, we've got the motors, we've got the wheels, and we've got the Arduino, and lastly we have the chassis. Now this chassis was designed to be just a very simplistic chassis, and the whole advantage of this is that I would show this later on, but you can see that this is totally symmetrical, and the advantage here is that if it topples over, it doesn't matter, it's gonna be always on the right side. Of course, the motors will you'll need to then go forward instead of reversing. But the whole idea here is that wherever it topples over, if it flips over, it's still on the right side. And this is kind of interesting here, because then we could use this more for like sporting events. For example, we can race it. If it hits a wall, if it topples over, it's still on the right side. It's a bit like Robot Wars, that kind of idea or so. Oh, thank you, Dej Akat. Yeah, the autofocus. Talking about the autofocus and then the camera, I don't know what's going on. I think it's pretty overheated because I was kind of testing a few hours just a few hours ago. So it's been running for some number of hours, but it should be fine. I'll have a look more into it. Anyways, so this is the main parts, the robot and all. So now, we've now been able to identify that. Now we need a Raspberry Pi, we need the Arduino, we need the actual motor driver. Let's actually go forward. Of course, we need the motor drivers and all. Now, the reason why we need the actual motor driver is that it allows us to measure this, control the speed and the direction of the robot. And this is something I wanted to go into a bit more detail, but we can. The good thing here is that, as you can see, that it has the ability for us to actually control the actual motors. For example, we can make it go forward, we can make it reverse and all. So that's a main advantage. Now, let me just put this back on. Okay, cool. So anyways, just going back to that, the whole summary here is that we're able to control the robot, and the whole idea here is that this allows us to control the robot, these main components. First of all, the Raspberry Pi. Now, the difference between, you may be asking, what is the main difference between a specific robot like the one we see here and the one we see here? Now, the main advantage here is that it's connected to the internet using our Raspberry Pi. We're listening to an actual server, and this is what we're going to go into a bit more detail. So everything I've explained before, nah, you're good, you're good, you didn't jinx it. I think it's back. So everything we did before is that we explained how a typical robot works. A typical robot, it has wheels, it has motors. The motors are connected to a motor driver, and then typically we have a brain, for example, a Raspberry Pi, controlling it. And we'll go a bit more into the code of this. But what I wanted to just show is this is the example of a simple robot. Now, how this differs is that we have an actual Raspberry Pi on top of the robot. So if we just have a look here, this robot would have a Raspberry Pi sitting on top. And our advantages here is that now we're able to control it. We can add some intelligence to it. For example, if we want to add some kind of some AI on top of it, this is also all possible using something. Obviously, you can use a Raspberry Pi because it runs Debian or so, but we can even use a Jetson Nano to make it much more intelligent. So realistically, even though I said this is the brains, this is the orchestrator, which is kind of like it's the end all be all, because we're controlling everything from here. This talks to the Arduino. So I kind of went over that point just to drive that point through. So now what we're going to do is probably go to the robot itself and actually try and do something with it. So of course, if you haven't seen, we're able to control the robot, for example, by making it move forward, as you can see here. What I'm going to do is now just make the robot move forward. Just checking everything. Okay, cool. So I want to show the specific latency of it. Assuming everything is working, you'll be able to see that the robot's moving forward as soon as I press enter right now. Let's try this, say hi. Okay, it looks like the Raspberry Pi has disconnected. So what I'm going to do is kind of talk more on the architecture, and then possibly in the future streams, what we'll be doing is going to be a bit more interactive, whereby we'll be able to actually control the robot itself. So let's actually go into how this actually is going to be controlled. And actually, this is going to be kind of how it works, the overview. So you may understand from the previous video that we're able to control it using pretty much a Flask server. What we're now using is Kafka. Now, the advantages of Kafka is it's a real-time message bus, so we're able to then send data in near real time. And to be honest, if you see, if anything, droid is pretty much 80% software. Like literally the whole idea is it to be software, and then the robots are singular nodes on the network, and then theoretically we can have as many nodes. So imagine a whole robot network or army or so that can all be controlled independently. So let me actually go into a bit more detail on what I mean. So let's do that. If I just go into here, you'll be able to see that if I okay, so you should be able to see the screen. So you may know that we could control this robot using YouTube, as well as Twitch to control the robot, as well as an actual web interface whereby we're able to control the robot. Now, how this robot is being controlled is like this. We send a command to the robot. For example, we type in W to move forward, and the robot moves forwards using simple WASD commands. These commands just here, just like a normal game. Right now I'm just flexing this autofocus because this is actually really cool. But for example, you can see here the WASD commands, not like anyone else has got a keyboard, but just testing out the autofocus. But anyways, W moves forward, A moves left, D moves right, S to reverse, and X, the character X, is to stop. So for example, it's like a hard stop. So this allows us to control the robot in almost like a game-like interface. Now, taking this into account, when we type in W, move forward, what happens is that we're using something called Kafka. Now, Kafka is almost like a message bus that it's really cool because we're able to send messages to the broker, and then for example, anything that's basically what they use is a consumer. So anything that is subscribed, any consumer that is subscribed to the broker would be able to get the message. So imagine, think of it more, this is kind of a weird example, but it's almost, think of it like a message, like a raw mail or something like this. We're sending a letter, like for example, a message. I would say a message rather than a letter. We're sending a message to raw mail. Then, for example, the consumer asks, okay, we're sending a message to raw mail, and of course we have a subject or so. And if the subject would be the title, in this case will be named the topic. And what we're going to be doing is that anyone who comes to this a metaphorical mail service also with the same topic ID that we sent here, they'll be able to get the message. So for example, robot 1 would then we'll be able to do, okay, send this message to robot 1. Robot 1 will be listening. And that's the whole idea of it. Let me know if you can still hear my actual audio, because my USB is kind of going really weird. It's a very odd live stream. Anyways, what we have anyways is that this is the architecture itself. We send a message to the robot, for example, by doing this. We send a message to the interface. The interface sends this to Kafka. Kafka is a real-time message bus whereby all these robots can then be listening to their message. So for example, we say move left or move forward. This is then sent to the robot using this kind of service, and this is up in the clouds. So for example, what we'll only see is that we'll have a web app, and it will literally just be like this. We have a web app like this, and what we have is the robot. So this is all we'll be able to see, these two things. We'll be able to see that when we type in something, in fact, let's have a look. let's say if we had an iPhone or something like this, we type in a message just like this. Okay, that doesn't work, but anyways, imagine if we had a web app, imagine it as a web interface. We'll be able to then send a command simply to the robot, just like that. And this is kind of the simplified version of it. And of course, you can see that it goes both ways. We can control the robot so it can move left. Okay, it looks like you can hear it. All right, thanks for that. Anyways, if you can see the screen, let me see if this will go. Wow, that freeze is not flattering. Anyways, we have the web app here. We can control the robot, and when we say move forward, the robot is able to move forward. But the good thing about it, it's backwards as well. So for example, if we have any data on the speed or the location of the robot, it's also being sent back to our actual droid server, which is up here, whereby we can see the data on our web app. So for example, we can see the location and everything about it. Let me see if I can get this back up. Oh wow, okay. Let's have a look. Oh yeah, believe me, this is technical difficulties. There we go. I think we're back in business. All right, can you see me? I think hopefully you'll be able to see me. So anyways, the reason why we're doing this is that we're going to be doing a lot of events overall with this, and of course this is just one live stream, which ended up being a lot of technical difficulties. But the idea here is that what we'll be able to do is that we'll have the robot. Imagine the robot just here, if you can see. Of course, it's got the free wheels. This is where I need Gallinacci. Gallinacci would be able to draw much more better than me to explain what we're doing. You can see here, we have a robot here. It's got 4 wheels. And the whole idea of it is that the robot would then be able to be controlled by, imagine us just in a different room or so, here, just sitting here. We'll be able to control the robot with the laptop. In fact, I think it'll be better to show it as. So imagine us, the robot would be able to be controlled by the laptop independently. So imagine the laptop here. So we can send commands like forward, right? Hey, we could send I appreciate it. We could send a command like forwards, backwards, and then also we can be able to say, hello, my name is droid, and so on. So the main things here, what we're looking at is that it's going to be movement. We can control the movement, and we can control the actual what it says. So pretty much via text to speech. Now, when we look into the robot, I think it's just easier to show it like this because it just helps a bit more. If we do another version of the robot, let's actually try and actually draw it properly this time. If we have a robot here, if we have this robot here, the whole idea of it is that this robot has main things. What I'll do is explain what's inside this robot and how is it going to be able to be moving, how it's able to move, and the next steps of how we can improve this robot. So this robot here has some main things. For example, let me just get rid of these. So if we just have a look at this robot, has a camera. So this camera is for sight, like a human. This is kind of like a thing, like a human, typical human being. We have eyes, This is going to be his sight. For the ears, what we're going to be having, if you have the ears, is going to be actually basically a microphone. Now the microphone is going to be attached to, it's going to be pretty much a webcam, if anything. So we're going to have it as the pretty much the what it hears. And lastly, of course, well, it's not lastly, but there's these are the main sensors. So we have the camera, the sight, and also we need something that's going to be, well, not the microphone being the ears, but the microphone being the way it's able to, yeah, it's going to be the ears. And lastly, the actual thing is what it says, like the actual mouth itself. Of course, what it says. This is the face. So then it's going to be what it says, which is going to be the actual speaker. This is going to be what we output to it. So what it says. I don't know if we could see it large enough, or I probably should have done it in white, but this is what it's going to be. We have the camera, which is going to be the sight, the ears, what it sees, and the speaker. To be honest, this is pretty much me testing out all these kind of tools at the same time. So hopefully these streams will get slightly better. Anyways, so that's what we're going to be doing. So what is going to be the next video? What we're going to be able to do is that, imagine this is the street, a street view of what we're going from. We're going to be able to go from the robot. This is going to be home. The robot is going to be able to, and imagine the robot, this is just a street view of pretty much the area I'm in at the moment. And what we have is the destination. Basically, it's going to be a delivery. It's a delivery station. So what we have is a robot. Now the robot is going to be, the goal of the robot is to go from here, which is our home, just over here. Probably need to get better at this, but this is the robot itself. The robot is going to be going from here all the way to the destination, which would be a delivery place. In fact, it'll be a takeaway. And the goal is for the robot to get the payload, and then it's going to make its way back. If I can do that in a different color, and deliver it. Now that's going to be the goal of the video, and what we're going to be able to do is that we will be able to control it using a laptop. We're going to be able to control it, and yeah, that's pretty much what the next video is going to be about. Now everything that we've gone through, this is going to be some more technical difficulties, but everything we've gone through is that we're going to make this robot itself here do everything. So it's going to be able to go and get a specific parcel and deliver it back. Now overall, what we've gone through is that we're able to control this robot using these main parts. We're able to use specifically, hopefully you'll be able to see me. If I just go back, hopefully you'll be able to see me. Let me know if you can't see me, by the way. So let's just go back to that. Probably should get rid of all of that. So what we'll be able to do is that this robot is going to be able to go from one A to B by us controlling it, and of course we can improve it by adding LiDAR. We can improve it by adding for example, ultrasonic sensors. In fact, we made a PCB board of it. I've made a PCB and I can't wait for it to come so that we can get rid of all the wires and all of that. But we've got an Arduino. We've understood that using an Arduino with a bunch of motor drivers attached to it, you can control it. We're using this Raspberry Pi, and of course, as you can see from here, this Raspberry Pi is the client. Is pretty much, think of it as the client on the robot itself that's going to be able to speak to the Arduino itself and then we'll be able to control it. So for example, imagine we had a computer right here. We will say move left, it sends it to the Raspberry Pi remotely over LTE or whatever, and then we're able to control it. We're able to control it via the Arduino. By the way, if you got any questions, let me know, because this is more like an interactive talk and all of that. But that is pretty much what I wanted to show realistically. This was more of just like more of a TED talk really. It wasn't as interactive, but what we'll do in the next steps is, what we're going to be doing is being able to control this robot over live stream as we did in the previous videos. It just turned out, I think that the battery went out on it, but anyways, this is pretty much it, and this is how we're going to control the robot. So that's all from me. This is a very short live stream, but I hope this kind of helps understand, make sense of where we're going with the robot droid. I like the name Droid Rover. That's a really good name. Android Mini, the Droid Mini edition. And the beautiful thing here is that it doesn't have to only just be food delivery. If you take everything out, the underlying technology here is that we're able to control robots as a community in real time. So this can lead to not just food delivery, but anything else that just use motors. For example, our own little competitive racing of like little robots and so. And this is things that we're going to be doing over the future live chats. So I know this video was slightly all over the place, and we had like the webcam going off and all of that. But one thing I just like is this autofocus. Wait, hold on. We could deliver prescriptions to all. That's actually a good idea too. The whole idea is that it's totally it's not autonomous now, but we're able to control it. Oh, by the way, if you want to see the model of it, it's the BTS microcontroller. So yeah, anyways, that's it. Now I'm gonna be rambling right now, so let me end it here. And what we'll do in the future videos, in this future live streams, is just go in a bit more detail on how we design this robot. For example, what makes a good design of a robot. I really like basically Johnny Ive kind of idea of basically how making a simplistic design. Long story short, you want like soft features. You don't want hard angles or so. And for example, if we think of it, we're going to go more into what makes a nice design, why cars are kind of ugly, quote unquote ugly, and some cars look much more nicer, and kind of the proportions of it. We'll go over these in future live streams, as well as pretty much building our own mini droid and all of that, but this is all for the future. Anyways, this is the live stream. Thank you all for bearing with me in this actual first official live stream with this new camera, and thanks for joining. My name is Evan. Peace.